Today we're going to be doing lesson 11 from module 3, where we are going to continue to work with fractions and making like units numerically, which means common denominators numerically. But now instead of adding them, we are going to subtract the fractions. And really it's the same process, we're just changing our operation. So let's practice with 1a. Where it says generate equivalent fractions to get like units. So finding equivalent fractions with common denominators, then we're going to subtract. So if we look at the equation, 1/2 minus 1/5. I know I need to have equivalent fractions here with a common denominator because I cannot subtract a fifth from a half right now. If I were drawing this model out, I would draw my rectangles, I would split it into a half and then split it into a fifth, but we know the pattern at this point. We know how to subtract fractions and how to find common denominators between a half and a fifth, because I'm going to take each half and I'm going to split it into fifths, which means my new denominator is going to be 10. Because 2 times 5 is 10. So to get from a half to a tenth, I'm going to times it by 5. So 2 times 5 is 10, which means I need to do 1 times 5, and 1 times 5 is 5. Now 1/5, I'm going to treat the other way, and I'm going to do 5 times 2 is 10, and 1 times 2 is 2. So now my new equation here is 5/10 minus 2/10. Well, 5 minus 2 is 3, and the 10 remains the same. So I get 3/10. Let's look at B. 7/8 minus 1/3. So I know I need to rewrite that as a new fraction, new equivalent fractions with the same denominator, and I can look at my eighths. And I know that each eighth I'm going to split into a third, which means I'm going to have 24 pieces as my new denominator. So 8 times 3 is 24. 7 times 3 is 21. 3 times 8 is 24. So 1 times 8 is 8. Now I'm just going to subtract straight across. The 24 stays the same, but 21 minus 8 is going to give me 13. So 7/8 minus 1/3 is 13/24. Let's practice now with a mixed number. We're going to use the same strategy here. 5 and 6/7 minus 3 and 2/3. I need to make a common denominator, so it's going to be 5 and something minus 3 and something. My common denominator is going to be 21. And I know this because each seventh I'm going to break into 3 pieces. So I'm going to do 7 times 3, and that equals 21. And then 6 times 3 is 18. So 5 and 6/7 can also be written as 5 and 18/21. Now to turn my 3 in a third into a 21, I'm going to times by 7. 3 times 7 is 21, and 2 times 7 is 14. It's really important that we're treating the numerator and denominator the same. So we times them both by 7, and then we also times then 6/7, we times them both by 3. So my new equation is 5 and 18/21 minus 3 and 14/21. So I'm going to subtract my fraction pieces first to make sure I can. So 18 minus 14 I can do. 18 minus 14 gives me 4. So it gives me 4/21. And then 5 minus 3 gives me 2. Now the reason I want to make sure I'm subtracting my fraction pieces first is because sometimes you're going to get a problem where you can't do the subtraction, where your second number is bigger than your first number. So then you're going to have to deal with borrowing. Think about it as when you are lining up decimals to do subtraction. You always start with the smallest piece first so you can borrow if needed. So we always subtract the fraction pieces first before we subtract the wholes. So 18 minus 14 is 4. So it's 4/21. And then 5 minus 3 is 2. So we end up with 2 and 4/21. as our final answer here. And I know that's the end. I can't simplify it anymore because the factors of 4 are 2, 4, and 1, and the factors of 21 are 3, 7, 21, and 1, and they don't have any common factors, so my final answer is 2 and 4 21s. Okay, last one we're going to do is this word problem. 4.5 yards of cloth are needed to make a woman's dress. 2 2/7 yards of cloth are needed to make a girl's dress. How much more cloth is needed to make a woman's dress than a girl's dress? So let's read again for important information. 4.5 yards of cloth are needed for a woman's dress. So I know the woman's amount. 2 2/7 yards are needed for a girl's dress. And the question is, how much more cloth is needed for the woman's than the girl? So I'm comparing the woman's and the girl's. So I'm going to do comparison tape diagrams, and that's when I stack them on top of each other. So I've got my women's tape diagram, which I know is equal to 4.5. And the girl's is 2 2/7. I'm not going to make it perfectly, but I know it's smaller. And the question is how much more is needed to make the girls than the women. So they want to know what this is, right? What's the difference between the women's and the girls? So to figure that out, I'm going to do subtraction to help me figure out what this missing piece is. Because this missing piece plus the 2 2/7 should equal 4.5. So I can then do 4.5 minus 2 2/7, and that should give me my missing piece. So I can think about this. I need to do the subtraction problem, and I need to have a common denominator. So I'm going to rewrite my equation. It's 4 and something minus 2 and something. I'm looking at halves and sevenths. I think my new denominator can be 14, and I'm thinking that because 2 times 7 is 14. So 2 times 7 is 14, so 1 times 7 is 7. 7 times 2 is 14, so 2 times 2 is 4. So my new equation is 4 7/14 minus 2 4/14. So I'm going to subtract my fraction pieces first. 7/14 minus 4/14 gives me 3/14 because 7 minus 4 is 3. And then 4 minus 2 is 2. So I get the final answer here that 2 3/14 more cloth is needed to make a woman's dress than a girl's dress. And specifically, we're talking yards. So I'm looking for my unit. So I know my final answer. So it's 2 3/14 yards of fabric is needed to make a woman's dress than a girl's dress. So we're still using our same strategies of finding common denominators numerically, but now we're looking at skills that we can use when we're subtracting fractions. It's the same as when we add fractions. We find that common denominator, we multiply our numerator and denominator to create those equivalent fractions, and then we just subtract. The key thing that I want you to remember is that you should, when you're subtracting, subtract the fractions first, so you're aware if you need to borrow or not. And we'll get into borrowing in the future, but you want to make sure you get into that pattern. Subtract the fraction part first, then subtract the wholes.